So I found online an awesome project. It was basically some sort of UHFSSTC with just one stage of voltage amplification, and the peculiarity was that it runs at 300 MHz or kind, and it makes a really small flame. The only problem is that it apparently requires a special transistor, a MOSFET, that is actually rated for UHF frequencies, and I don't have it. So usual problems. If I buy it in China, they'll scam me with fakes. If I buy it from reputable sellers, they'll charge me a lot of money. I could buy them used, but they cost something, and I'm not actually into this thing, so I'll pass eventually. But then I thought, why not using one of the MOSFETs that I have? After all, that MOSFET there, rated for UHF frequencies, is just 30 volts, 4 amps rated, so it's probably a really small silicon crystal, so maybe I need a really small MOSFET, but all the MOSFETs that I have are chunky, because MOSFETs are usually power transistors, except maybe one, that is the 2N7000. Yeah, I know, this is stupid. This is a TO92 MOSFET that is fairly famous also, and it's not rated for high power at all, just 400 milliwatts probably, and not rated for really high frequencies at all. But then I checked one thing about the two MOSFETs here, this and the one used in that coil, their typical capacitances. And we are there, apparently. And maybe also a bit better, I don't know. And worth trying, considering the effort to build something like this. You can see here. And considering that the stray capacitances of the two MOSFETs are basically identical, I also copied the project from two pictures I found online, literally copied with like a number of turns, etc. And the 2N7000 is inside this piece of aluminum, heat sinked a bit, with also a bit of thermal paste. And the fun fact is that I haven't popped any MOSFET yet. It's the original one that I fitted and it's still alive. And to tune the coil, especially adjusting the trimmer, I use this detector here that is just a loop of wire with a germanium diode in series and a capacitor on the output for smoothing connected to a whatever indicator, microamperes, you know, in this case analog multimeter. And this gives me the idea if the oscillation stops or if I reach the maximum power, and it helped a lot also because initially I got something wrong. I pushed too much the gate voltage and the oscillation stopped, and I was puzzled why it was behaving weird, not oscillating. Anyways, this helped a lot. Okay, let's try this thing. Let's read its frequency. I have here my spectrum analyzer that I have to keep on the screen because otherwise it goes out of the screen. I don't understand why it stays 5 freaking seconds. I hate modern technology for these things. Why they do these things? Anyways, let's turn it on at 10 volts DC, 66 milliamperes of consumption. The indicator is indicating something. Let's see on the spectrum analyzer. 250 MHz, 70, 80, 90, 300 and 310 MHz. And we have a black screen. It means we found the carrier. This is the frequency, kind of 310 MHz. And let's see if it's it. Let's turn it off and on again. Off, on, off, on, off. Okay. Okay, now a power run, let's call it power, at 13 volts DC. I don't want to go past this power because the power on the MOSFET is already above 1 watt and it will probably pop almost certainly, so I can't hope for a flame, just forget about it. Anyways, the only thing that I can show you is lighting up this neon bulb. This is a floral bulb. Aerolux style modern bought on AliExpress, and this is good for this task because not only it's neon, so it's easy to ignite, but also its internal metal structures are very far from the outer surface of the glass, so I can get this thing near the coil there and ignite just the gas without having the structures near the coil that mess with its tuning, performance, etc. So this is appropriate. And if you care, and you probably care, with one of these you can make a plasma toroid like in this video here. So let's see. Let's turn it on at 13 volts DC, and we have kind of 100 milliamperes rising because the gate becomes too sensitive with a higher temperature. And as you can see, it lights up. Also the leaves. The color is very pink, and it stays on also at some distance from it, but the electric field is very weak. So let's try now with more light to have hopefully a more natural appearance of the plasma. Let's turn it on again. We have again the kind of 100 milliamperes. Let's see the bulb. And it likes to be slightly above the coil, actually. The indicator is indicating. This is the maximum. Yeah. Let's see the leaves. Yeah, also. Okay. So thank you for having watched my video, and if there are updates about this project, as always, you'll find them in the description of the video below. So at this point, I think goodbye for now.